Okay, so this is an intro on Lab3. So in Lab3 you need to create a filter. So it's pretty much a passband filter for KU band, and it will stop the KA band. So what it simply means is that you will have to look at S21 and S11 of a filter. Now the filter is already created for you. So when you start the lab, you can download the AWR file, and you will notice the file would look something to similar to this, and it will have under circuit schematic a filter circuit in the form. So that's the input, and this is the output, and it has an input transmission line and a T-junction and an open stop, and another transmission line, T-junction, open stop. So this particular configuration will act as a pass band for the KU band, and it will stop the band for KA band when we tune the lengths of these lines. Now what happens, this is already tuned for you. Therefore, when you look at the response, you will notice you will have an insertion loss of very minimum insertion loss better than 3 dB in the KU band 12 to 16. In this area, we're looking at S21 that represent insertion loss, and then S21 gets significantly lower in terms of loss. It becomes significantly higher in the KA band region, and then after that we don't really care. Now for this exercise, actually I think when I give you the lab, I would also look at the x-axis being maybe 40 is enough. Okay, now the idea here is that, okay, so you given the filter, but it's all in schematic. So that means these two lines don't know how far apart they are. Schematic, this line doesn't know if there's anything close by. So schematic do not have any coupling effects taken into account. Okay, so that's the filter. So your aim at the end of this lab is to create a filter, like how it actually looks like, if you call it a layout, and put that layout in this frame. So this frame is 940 by 945, and you need to put your filter here within that region. What you will notice, this to start with, for this circuit there is already a layout, and you can go and click on the layout button and you will see that layout, and this is the layout for this circuit. Now if I click up, you will immediately notice this layout is too big to fit in this frame. So you need to make sure that you create a layout, and still a layout that can fit in this frame and also perform as we expect to, where the S parameters S21 is greater than 3 dB here and smaller than 10 dB here. Now a few things to note. This is called the frame, and this is called the RF pads. So this is the RF in pad where the signal comes to this point, and these 2 points are called ground. And you'll notice this is a VR. VR is something that connects your ground pad to the bottom ground pad. So this is a top view. So there's normally, this is ground, signal, ground. So GSG pad, we call it a GSG pad. So there's a GSG input pad, there's a GSG output pad, and your filter, so input and output will need to start from the input here, has to start from here, and the output here starts in there. That's what we are trying to achieve now. Okay, so that's the background. So how do you first achieve, how do you first really make this to a proper shape to fit in here? That's what we're going to discuss. So that's all. So basically the background I explained just now is sort of given in this part of the introduction. So you will have to get this marked at the last 15 minutes. Remember, this lab is going to take a lot of time because the EM simulation is going to take a while. So you need to do as quickly as possible. Don't waste time. and whatever you do at the end of the lab in the last 15 minutes, that's what you get marked on. I will explain now the marking criteria as we go on, but for now let's go into the lab. Okay, now the first thing you should do in here, so this has a certain schematic layout. When you click on element, which is a microstrip element, and if you go to the layout and see, you'll see that part is highlighted. The first thing to notice is that your layout, there is some red crosses. That means these are not snapped together. So this is your first transmission line. See this part highlighted. If I click on the T junction, I'll see that's the T junction. Now, so these things, if they are snapped together, you will see that crosses disappear. So the idea is, first thing you do is make sure that crosses disappear. Now that's one way of doing that, and the other way of doing that is you select all and then you do snap together. Once you do the snap together, it should disappear, and that should give you a proper, the layout. Okay, now as I said before, the schematic don't know there's a microstrip line next to each other. Now in this case, they are far apart, so it should be okay. But when you bend it, for this example, because this is too long to start with, you may have to bend this line in the middle. When you bend it, they come closer. This and that come closer, and when they come closer, they can couple to each other. So you need to make sure you capture that effect in the EM. Now you have no idea how to do an EM at this stage, but I'm going to show you how to do the EM simulations. So the way you do an EM simulation is that you go to the filter circuit. You need to, so let's create a new circuit, because I don't want to touch on the first base circuit. So I'll create this new circuit. I'll do duplicate, and I call this, I'll rename this to be schematic 1. So you can rename it to whatever you want to be. Let's do schematic 1. Once I do that, I need to add something called extraction block. So the extraction block, you can click on the element and then start typing extraction. So I already previously typed it, but if you haven't typed it, it will look like this, and then you get an extraction control block and then you put it in here. Then there's a few things that you need to set up. Simulator, you can set the simulator to do axiom. That's what we'll be using. This is fine. Stack up. Now stack up is something you need to fix, so you need to do axiom PE 1500. Okay, so once you set that all up, I think that's all good to go. But when you click on that, you notice that it becomes red. Now what this extraction block does is it actually extracts an EM structure from the layout. Now this is very important. It will extract this from the layout. So if your layout is wrong to start with, EM extraction would be faulty. So you need to make sure your layout is properly done. When I say properly done, what I meant is there's no crosses in these points. So they are nicely snapped together. Otherwise, when you extract it, you will have problems. Okay, now you'll see when it's red, nothing is red, but something that you can do, you need to do in the extraction process is make sure you're in schematic 1. I need to tell each of the components, okay, you need to be extracted. So how do you say that? You'd go to properties and then say enable, then say okay. So it says EM extraction options, enable, okay, say okay. And when you click this extraction block, now it becomes red. So that tells you that this microstrip line knows that it needs to be extracted. So likewise, you need to do extraction for all these components. So I'm going to pick all these components. Now remember, I do not pick mopenx intentionally because you don't need to. You can try if you want to, but I normally don't do it as a practice. Then select enable. So now when I click this, it knows that I need to be extracted. So the next step you need to do is do the extraction. So the way you do the extraction is right click, then do add extraction. But before I do that, just notice in here EM structures, there's nothing in here because there's no crosses, there's no structure inside. So once I do the EM extraction, you will notice that there's something that gets populated under EM structure. So when I do that, so this is the EM structure. It looks similar to your layout, but notice these things, this is only a layout, it just says how it looks like. But EM structure is an actual structure that has a three-dimensional view. like that. So in this case, that's just to show you, and it also has ports. Okay, now you will also notice that under EM structures here, there's the EM structures that this file popped up. This file popped up. Okay, now when you do a simulation, now what happens if you do a simulation for schematic? AWR software will do an EM simulation for this structure, and then that structure is pretty much part of this. And then once it finished calculating EM, once it finished the EM simulation, that data will come in between this port and that port, and the results you get out from this schematic is pretty much an EM result, not just a schematic result. Now, if you get a result, you need to plot it, right? So I need to plot it in the same graph. So what I'm going to do the schematic 1, S21, S11. So I would normally drag and drop this and do schematic 1. That's S21. Do schematic 1. So I have I should have 4 curves now. These are not enabled because it doesn't know the response. It hasn't done the EM simulation. So if I run this EM simulation now, it starts running the EM simulation. It will take a while depending on your PC, how full, how fast it is. It will take maybe 10, maybe it can be 50 minutes. So you make sure as well as it might take a while. So you do things in terms of reducing number of frequencies. So one thing that you can, I cancel this. One thing that you can do to make it faster is go to options. Oh, actually, yeah, frequencies. You'll notice it goes up to 100. So you may not have to do it to 100. You may have to do it. You can probably do it 1 to 60, and then replace in every 1 gigahertz. You can do it that way. Yes, change it. Okay, so it will be overridden in the next extraction, but you can do things like that to speed it up if it doesn't work. Okay, so that's the background. Now once you do that, because it takes time, I have done it already, and you'll notice that I have the schematic 1, and when you finish that, you'll notice there's a data set here, and you will notice something similar to this. What happens is the EM simulation results, the blue curve and the red curve, are very similar but slightly different, but that's good enough. Now that only tells you that what I showed so far is how to do an EM simulation. It doesn't tell you anything about changing the layout, so it doesn't help in this exercise. This is just to tell you how to do an EM. This exercise, if you look at the layout of this, still too big, right? So I want to change this so that it fits in this layout. So that's basically what you need to do. So to start with, I will make this line here like a U-bend, and that way I can get this end and this end close together, and so that it fits in here. So if I want to do that, I can do it on this schematic, or I'll probably create another schematic. Sorry, not rename. I'll duplicate it. I'll call this schematic 2. So I'm going to modify this schematic. To modify this schematic, I'm going to add so when I modify the schematic elements, I will eventually modify the layout for that. So I'll just make them a bit farther apart. So I'm going to make a U-bend, right? So this is straight line, and you will notice that straight line is 710 long. So whenever I make the U-bend, I want it to be close to 710 micrometers long. Okay, so I would need bends, right? So I can find elements from this bottom here, elements. Then I can go to under microstrip, then go to bends. I can find things like M curve. This is intelligent curve microstrip bend. So you can do different. You can find other bends like square bends, doesn't matter, it's up to you. But let's say I find this, I can drag and drop it. So I want a bend here. So if you right click on your mouse, it'll rotate. So I do right click, I get one bend here. Okay, and then I want a similar bend. I copy it on this side and then right click so that it changes. So that's one, and then I also want something like a small microstrip line here. Then so I don't need this, I'll just delete these outlines. Okay, and I will need, so I'll make this length 1. I'll keep it variable because it's easier for me to tune later. Okay, so I'm going to make this here. So I need to tell what is L1, right? So to start with, I will just do, I don't need, I'll just take this L1, I'll take 150 or something. So I have 150, 150, 300. So I'll make this, so I want another line. I'll call it L2. Let's do L2. I want another variable, copy paste. 100, or maybe just keep it 150, doesn't matter. Okay, so I have 150, another one here, and I need another bend, copy paste, right click to turn, then I call this not LMS because L3. Okay, so the L3 I'll keep it. So these numbers up to you, whatever you want to do, it doesn't matter. So if I keep this 100 or 110, so 150 to 300, 600, 710. So it's close to LMS 710. So I'll just keep this. Okay, so I have the schematic ready. So I'm just doing my shape the way I want it. Okay, I have the schematic ready. Okay, this looks right. Now you notice when I do click on the extract block, these things here are not these things here are not red in red color. Okay, let's we'll talk about that in a minute. We go to the layout. You'll notice the layout is everywhere. Okay, so that's because all the new things that you put, they are just they just came into the layout. Layout doesn't know how to arrange it. So you can manually arrange it, or we can try the auto snap, see if it works. It seems to work. Probably, yeah, it seems to work. So we have to pretty much select all to auto snap and then move it. So it seemed to work, and now you notice that immediately this has a shorter length. It's roughly okay, maybe not there yet, but it's okay. But the problem is these two lines, so you have to bend those lines too so that it fits in this frame. So that's up to you. You'll have to make sure that it somehow at the end of the lab you fit all that in here. Now, so you finish that, but it doesn't still know that that's just a layout. So when you click on that, if I do extraction, now remember when you do extraction here, this em doc name, extract doc is already there before because you already did extraction. If we do it extraction now, it will overwrite this extract doc. So what I do, I rename this em extract doc to be v2, whatever it is. Then I'll do right click and do add extraction. You'll immediately notice that this is missing the bends here. That's because this doesn't know that it needs to be extracted. So you'll have to pick these 4, tell it that okay, you need to be extracted. Enable. Now when I click it, everything's red. That's good. And then I do add extraction, and it should give me a properly extracted EM structure. So now you can so now that's not enough, obviously, because these two things are still long. So your task in the lab is to do either this and then somehow bend it, and once you do it, you need to make sure that schematic 2 also meet this specification. it also has a response that is better than 3 dB here and lower than 10 dB here. So as long as you meet that, that's the expectation of this lab. So the way you will be marked is to do a proper layout to fit everything in here. If you do it properly, nicely, you know, the starts here and goes here, and then everything's in here, and you have at least a gap of about 20 micrometers from the edges. If you have all that, you'll get full 5 marks. And when you do the EM results for the final layout, and if it meets that all the specifications, you get maximum 5 marks and total 10 marks. There's no quizzes for this lab, but this lab will take time, so you need to make sure you do everything as fast as possible during the lab. Okay, so that's the brief introduction on the lab. I think that should be clear enough. I'll see you in the lab. Thank you.